talk on certain extended special functions. This research work is my research work with joint work with Jun Seng Choi, Professor Dragan Janko, and Professor Tibor K. Pogani. Special functions are some particular mathematical functions which have more or less established names and notations due to their importance in mathematical analysis, functional analysis, physics, or other applications. However, there is no general formal definition, but the list of mathematical functions contains functions which are commonly accepted as special. In particular, elementary functions, especially trigonometric functions, are also considered as special functions. These functions commonly arise in such areas of applications as heat conductions, communication systems, electro-optics, nonlinear wave propagations, electromagnetic theory, quantum mechanics, approximation theory, probability theory, and electric circuit theory. The theory of special function has been developed essentially in the 19th century due to the contribution of Gauss, Jacobi, Klein, and many others. Special functions have been used for centuries. For example, since they have numerous applications in astronomy, trigonometric functions have been studied for 1,000 years. However, in the 20th century, the theory of special function has been overshadowed by other fields such as real and functional analysis, topology, algebra, and differential equations. Now, first we begin by recalling the definition of gamma function. The gamma function is defined by gamma z is equal to 0 to infinity e raised to power minus t raised to power z minus 1 dt, real part of z greater than 0. It is defined in equation number 1, which was appeared in 1729 and 1730 from Leonhard Euler to Christian Goldbach and developed by Euler, who had been eager to extend factorials to value between the integers. The beta function bxy is a function of two complex variables x and y and is defined by bxy 0 to 1 t raised to power x minus 1 1 minus t raised to power y minus 1 dt, where real part of x and y are greater than 0. Also, the relation between beta and gamma function is defined as beta xy is equal to gamma x gamma y upon gamma x plus y. Also, here 1 and 2 are known as Eulerian integrals of the first and second kind. The definition of the generalized hypergeometric function with R numerator and S denominator parameters is given by equation by the series representation presented in equation number 3, where A1, A2, A3 are parameters, numerator parameters, and A, B1, B2, Bs are denominator parameters. Also, here, An defines the Pochamber symbol and is defined by An is equal to gamma A plus n upon gamma A. The convergence condition is presented here. The classical Gauss hypergeometric function 2f1 is defined by 2f1 abcz summation n0 to infinity an bn upon cn z raised to power n upon factorial n. The Euler integral representation of Gauss's hypergeometric is given in equation number 6, which is given by 2f1 abcz gamma c upon gamma a gamma c minus a 0 to 1 t raised to power a minus 1 1 minus t c minus a minus 1 1 minus z raised to power minus b dt. The confluent hypergeometric function known as Kummer's function, which is defined as 1f1 and is given by given in the equation 7, and the integral representation of this confluent hypergeometric function is presented in equation 8. Now, if we use straightforward transformation, bn upon cn is equal to b plus n c minus b c minus b in the definitions of Gauss's hypergeometric function 5 and confluent hypergeometric function 7. These functions can directly written in terms of this ratios of beta function as represented in 9 and 10. Now, in 1994, Chaudhary defined the p-extended beta integral by introducing the exponential factor in the integrand of the beta function, beta integral. Here, if p is equal to 0, if we put p is equal to 0, this definition reduces to the classical definition of beta function. They studied various properties. Chaudhary et al. Studied various properties and obtained certain connection with the McDonald function, error function, beta function. Further, more interesting properties and various connections with higher transcendental functions are investigated by Miller also. In 2004, Chaudhary et al. Used this p extended beta function and replaced the beta function by p extended beta function in 9 and 12 and introduced p Gauss's hypergeometric and p confluent hypergeometric function here defined by equation number 12 and 13. Now, here if we see that if we put p is equal to 0 in 12 and 13, we directly obtain the classical Gauss's hypergeometric function and the classical confluent hypergeometric Kummer's function. Also, they studied various properties including differentiation formulas, Mellin transforms, transformation formulas, recurrence relations, summation formulas, asymptotic formulas, and certain interesting connection with some well-known higher transcendental functions. Recently, Choi et al. Introduced further extension of BXY, further extension of P extended beta function, P extended Gauss hypergeometric function, and P extended confluent hypergeometric function in the following manner. They introduced one more parameter Q and defined the extended beta function, PQ extended beta function presented in 14, PQ extended Gauss's hypergeometric function represented by 15, and PQ extended Kummer's hypergeometric function represented by 16. Clearly, if we put P is equal to Q is equal to 0, these equations 14, 15 and 16 immediately reduces to the classical beta function, classical definition of Gauss's hypergeometric function and the classical definition of Kummer's confluent hypergeometric function. If we put P is equal to 0, if we put P is equal to Q, these definitions 14, 15, 16 reduces to the definition of Chaudhary et al. P extended beta function, P extended Gauss hypergeometric function, and P extended Kummer's hypergeometric function. Also, they obtained various integral representations of these functions, differentiation formulas, Mellin transform, recurrence relations, summations are also obtained by them. If by employing the transformation T is equal to cos squared theta, T is equal to U upon 1 plus U, T is equal to 1 plus U by 2, U minus A upon C minus A in the definition of PQ extended beta function. In the definition of PQ extended beta function, we obtain another new integral representation for PQ extended beta function, and here given by 17 and 18, 19 and 20. Further, some more integral representation for the extended PQ extended hypergeometric functions are presented here in 21, 22 and 23, 24. Further, if some more transformations using some transformations, elementary transformation, these the confluent hypergeometry PQ extended confluent hypergeometry have some new integral representations here given by 25 and 26. They also they also obtain some properties of PQ extended beta function. They given the functional relations b beta x plus 1 comma y for two parameters PQ plus b x comma y plus 1 PQ is equal to bxy PQ. These functional relations is obtained for the PQ extended beta function. Also, they obtained summation formulas for this beta PQ extended beta functions presented here by the equation 28. Further, they obtained infinite summation formulas for this PQ extended beta function presented here in equation number 29. Also, they obtained a Mellin transformation formula for PQ extended beta functions and obtain this Mellin transform PQ extended beta function in terms of classical beta functions. And here it is representation by this formula. Also, this PQ extended beta functions have some connections with special functions. The first connections with special function is as a Legori polynomial, and it is represented in equation number 13. This beta PQ extended beta function can be written in the form of double summation series involving Legori polynomial, and it is presented here by 30 equation number 30. Also, this PQ extended beta function can be directly obtained in the terms of g function, minus g function of two variables, and here presented in equation 35. Also, they obtain the connection with Apple function also for in Apple function of two variable, second Apple variable, and it is presented here by 36. Also, this beta function can be written in a single in form of a series representation in product of Legori polynomial beta function, Pythagoras function, and presented here by 37, equation number 37. Further, they also obtain a connection with the McDonald function, the modified Bessel function of the third kind, and by putting x is equal to alpha and y is equal to minus alpha, this beta function can directly be written in terms of McDonald function. The familiar Bessel function J nu z and the modified Bessel function I nu z of the first kind have the series representations given by J nu z is equal to z by 2 is to power nu root pi gamma nu plus half summation n greater than is equal to 0 minus 1 raised to power n b beta n plus half comma nu plus half z to the power 2n upon factorial 2n. This function can be this function is written in terms of beta function, series represented in terms of beta function. Also, I nu can be written also in terms of beta function. Now, by using the concept of PQ extended beta function, by using the definition of PQ extended beta function in by replacing this beta function by the PQ extended beta function, we introduce PQ extended Bessel function J nu PQ and the PQ extended modified Bessel function I nu PQ of the first kind of order nu in the form represented by the equation 41 and the 42. If we put P is equal to 0 is equal to Q, if we put P is equal to Q is equal to 0, this PQ extended Bessel function and modified function reduces to the classical definition of the definition of Bessel function and modified Bessel function. Further, we obtained various integral representations of these extended function. Here, two integral representation for the Bessel function is given by modified Bessel function, and Bessel function is given by 43 and 44. If we put again P is equal to 0 is equal to Q, these integral representation reduces to the classical integral representation of Bessel function and modified Bessel function. Also, bounding inequalities are obtained for these PQ extended Bessel function and PQ extended modified Bessel function. Here, these by bounding inequalities are represented by 46 and 47. Also, they obtain the Mellin transform of these PQ extended Bessel function and the PQ extended modified Bessel function. It is important to see that the Mellin transform of these extended functions are written in terms of classical generalized hypergeometric function 1f2. Here it is defined as Mellin transform of J nu PQ Z double Mellin transform. It is written the double Mellin transform of J nu PQ is defined as gamma R, gamma S, B, beta function. Beta RS means beta function. Beta half plus R, nu plus S plus half upon root pi gamma nu plus half Z raised by 2 whole raised to power nu and 1 F2. Similarly, for double Mellin transform of extended PQ extended modified Bessel function is given by integral by this form in this form. After systematic examination of PQ extended Bessel function and the modified Bessel functions, it is natural to switch to the Bessel type of other functions, family of Bessel function. The obvious process is for the stub function and the modified stub function. The stub functions is defined by the series representation here by h nu z and modified stub function as L nu z. These functions can be written in terms of beta function also. Now, by using the PQ extended definition of PQ extended beta function, here we extend stub and modified stub functions as PQ extended stub function and PQ extended modify stub function. Here it is defined by H nu PQ and L nu PQ, and it is presented in the equation number 15 and 51. It is important to note that if we put P is equal to Q is equal to 0, if we put P is equal to Q is equal to 0, this PQ extended stub function reduces immediately to the classical definition of stub function. And also, if we put P is equal to Q is equal to 0, if we put P is equal to and Q is equal to 0 in the definition of modified stub extended PQ extended stub function, the equation 51 immediately reduces to the definition of classical modified stub function of order nu. Further, integral representations are also obtained for these PQ extended modified PQ extended stub function and PQ extended modified stub function. And it is given by H nu PQZ and L nu PQZ, and it is given in the integral form of 2 z by 2 raised to power nu upon root pi gamma nu plus half 0 to 1 minus t square whole raised to power nu minus half sin zt e raised to power minus p by t square minus q upon 1 minus t square dt. Also, the second integral representation for this function is given by L nu PQ Z is equal to 2 Z by 2 whole raised to power nu root pi upon gamma nu plus half 0 to 1 minus t square whole raised to power nu minus 1 by 2 sine hyperbolic zt e raised to power minus p by t square minus q upon 1 minus t square. If here we put p is equal to 0 and q is equal to 0, this integral reduces to the classical definition of stub functions and reduces to the integral representation of classical stub function. And similarly, for this integral representation, this integral, if we put p is equal to 0 and q is equal to 0, this integral representation reduces to the classical definition of the modified stub function. Further, bounding inequalities for these PQ extended PQ extended stub function and PQ extended modified stub functions are obtained for these extended functions. Also, these stub function, these PQ extended stub functions can written directly in terms of PQ extended hypergeometric function, and also PQ extended modified stub function can directly written as in terms of PQ extended hypergeometric function. Here, PQ extended hypergeometric function is defined by by in this slide. The PQ extended generalized hypergeometric function is defined by the series representations presented in 48. Also, here we also obtained the Mellin transforms formulas for the modified Bessel for the stroke function h nu pq and modified stroke function l nu pq with respect to the parameters pq. The double Mellin transform of h nu pq is given by z raised to power nu plus 1 gamma r gamma s upon beta half plus r comma s upon 2 raised to power nu root pi gamma nu plus half, and you multiply by 1 f2 the parameters upper parameters are 1 plus r 3 by 2 nu plus r plus s plus 3 by 2 minus z square raised to power 4. These two Mellin transforms are obtained in terms of classical hypergeneralized hypergeometric function 1f2, and also the Mellin transform for the PQ extended modified PQ extended modified Stroop function can be written in terms of, again can be written in terms of classical hypergeometric function 1f2. Also, the here also various differential equations for the can be derived for this function. Here we have obtained two differential equations for these functions. The differential equation for the J nu PQ for the defined, we have defined the Bessel function, PQ extended Bessel function and PQ extended modified Bessel function. The differential equations is obtained by x square w nu double dash minus 2 nu w nu dash plus x square plus nu plus 1 w nu is equal to 2 nu plus 1 into w nu plus 1, where w nu is defined by j nu pqx or I nu pqx. And these two equations are obtained for these differential equations. These functions satisfies the differential equation 52 and 53. The complete monotonicity is suitable function fx is complete monotonically or totally monotone if the functions defines the conditions minus 1 raised to power n and fn x greater than equal to 0 for all x greater than is equal to 0 and n belongs to n0. The motivated by the results concerning Turan types inequalities for stub functions of the second by derived in paper of Barricks. Here we provide procedure to derive complete monotonicity and log convexity and Turan type inequalities for these for the normalized variants of Bessel function and modified Bessel function. The Bessel functions, the definition of Bessel functions can be defined. The normalized variant of Bessel function, PQ extended Bessel function, can be written by the equation 53. Now, for the equation 53, normalized variant of PQ extended Bessel function, we obtained, we derived the Turan type inequalities for these normalized Bessel function, and it is holds true for j square nu pq x minus j nu minus 1 p pq x j nu plus 1 pq x less than is equal to 0 for nu greater than 1, and equivalently if we multiply the factor nu plus half by these factor and putting the equation, the Turan type for the Bessel PQ extended Bessel functions can be also obtained. These are the references which we have used for this. Thank you, sir.
Thank you, Rakesh sir, for your presentation. You could have taken some more time to explain the concepts because we
Yes.
have enough time. Anyhow, any comments or questions from the participants? Any questions? Any questions or comments from the participants? Yes, Javed. Raised hands.
Sir, can I ask?
Yeah, sure, sure.
Sir, I'm new in this field. I just started now. So my question, I always see all the references we compare. We always take PQ is zero. Is why we always take to compare that to verify the previous result. All PQ zero, not other values.
Sir, since these we have various functions, transcendental functions such as hypergeometric function, beta function, gamma functions. These are we here we have generalized we are given the generalized form of these functions by introducing one parameter p or two parameter p and q, and it can be more generalized by using another parameter p q r something. Since we put here p and q is equal to 0, because if we want to show that all the properties for the classical hypergeometric function, for the classical special functions, whatever we have here used, are naturally extended. All the properties can be naturally extended. So we here show that if we put p is equal to 0 and q is equal to v, or we have the already the result in the literature. So it is an interesting is to that we have generalized the various previous classical results in terms of our extended function.
Any other questions? Javed sir, is it clear for you?
Yes, sir, absolutely. Thank you very much.
Okay.
Thank
So, any other questions or comments, or those research scholars can ask questions? Research scholars doing research in special functions can ask questions to Rakesh sir. Any other questions? Rakesh sir, you have extended the extended beta that beta functions which of this Chowdhury, and did you apply these results in any other areas like since beta functions are applied in many physical areas? So is
Also,
that
yes,
extended beta, or simply you have just generalized it this extended beta with PQ generalizations?
sir. Thank you, sir. Sir, these we have derived various. First, we have introduced beta PQ extended beta functions and obtained and introduced PQ extended hypergeometric function, confluent hypergeometric function, PQ extended Apple function, also PQ extended Srivastava hypergeometric function, PQ extended Srivastava triple hypergeometric functions. These will, and also these beta functions we obtained their fractional calculus operators also. Also we obtained we derived various fractional kinetic equations in the field of fractional kinetic equations, and also obtained their fractional kinetic equations, and more other applications are obtained in one paper in IEEE. Said one more author I don't know, but they have applied in engineering field also.
Okay, sir. I would like to suggest that if you, since you are doing this research in PQ extended beta, in fact, I have used this function some of my work. I would like to suggest that if you can plot this PQ extended
Graphical.
part of that function. Have you plotted that, or and you compared this with the extended beta and the standard beta?
No,
If you
sir.
can do that, you can use it to many other areas, because
Yes,
it
sir.
is closely related to the reaction rate probability integrals, and also Kretzel function or many other transforms this is related to. So I think if
Yes,
you
sir.
can plot this and know the behavior and what type of values, instead of putting p equal to 0 and q equal to 0, you can put various other values also.
Various, various.
That is what Javed sir was noting. So you can put various other values. You have to think about various what values, what are the other values of P and Q, which will reduce these to known results. So that is also
Yes.
another opening in this area, I think.
Yes, sir. Actually, I wanted to ask this thing. Thank
But
you.
I want to give a suggestion. If Javed want to see, Chaudhary has also obtained various graphical representation by putting the parameters value, different values of the p, or not only for the zero, various other values, 0.01, 0.2, and obtain various graphical representations. And still, this work is not done for the PQ two parameters. Only one parameters has been done by various by the Chaudhary sir.
But I presume that this has been further
Yes, sir.
extended. I think it is
Yes,
further
sir.
extended by putting P by T raised to some rho, and 1 minus some T raised to some rho is also there. I think
Yes, sir.
there are works on that also. I think I have seen
Yes,
that work. So
yes, sir.
anyhow, thank you very much. In this short have explained nicely, and I think that students are also benefited by your work. So thank you very much on behalf of the Department of Mathematics and on behalf of the participants. I thank you for your nice presentation.
Someone has asked
Thank you, sir.
how to
Thank you.
find convergence condition in this
Yes.
equation extended
Yeah. Yeah.
beta PQ extended beta function.
Sir,
How to find convergence?
Yes.
sir,
I think have you, Ragesh sir? Did you hear that
no,
question?
sir. No, no, sir. Please, again, sir.
Arya, please repeat that question.
How to find convergence condition in the PQ extended beta function?
Since this function, if this is convergent for the value for the real part, only this convergent integral, this integral is convergent for the real part of p and real part of q greater than 0. Only the not here for the real part of x and real part of y, we exclude this condition. Only we have taken the real part of p and the real part of q greater than is equal to 0. And this integral is convergent for these parameters.
Is that conditions clear?
If we put here x is equal to 0 and y is equal to 0, still then this integral also have some value.
Okay, sir. Thanks.
Okay. Since there is no other question, let us thank the speaker once more. Thank you, Rakesh sir. So today we have come to the end of today's session. Now tomorrow's sessions, we have more from tomorrow onwards. We have the first session will be delivered by Krunal Kachia from Charusat from Gujarat, and the second session is a paper presentation session, and the third session is by Arpad Barracks. I think Professor Parmar sir has referred the Turan type inequalities which that Barracks has discussed. So I think that session is will be going to be interesting. So I invite all to be on time at tomorrow at 10:30 a.m. in the morning for the third session. So thank you very much. Thank you very much for the participants. I we have put the feedback form in the chat box. So those who have not filled, please fill the feedback form. Somebody has asked the reference textbooks. Sir, is there any reference textbook?
For
Rakesh,
this,
sir?
yes, sir. Yes, sir. Again, sir.
So in the
Reference
chat box,
text.
it is there. It is the reference textbook they are asking.
One textbook, book is very well known of Chaudhary et al. It is the title of the book is on an applications of incomplete gamma functions on and an extension of extended incomplete gamma function. This book is written by Chaudhary et al. And it contains p extended gamma function, p extended beta function, and various graphs and others for the p extended and p extended beta functions in the and applications in the transition heat equations, various. This book is very interesting. You can find all these problems in that book.
Okay. So thank you, sir. Thank you very.
Uh, this book is, sir, 1 minute. This book is, I think I have given in the reference. This book is, I can see, 1 minute, sir. I think this is, yeah, sir, this is the book. This is very interesting book. And if anyone wants to do the work in for the P extended and PQ extended, then this book is very helpful. I've also studied for the initial work in my research PhD work. I started studying from this book. Thank you, sir.
Okay. I think now the doubts are cleared.